All right, so if you're doing anything with data in Python, you're pretty much living in pandas, right? But let's be honest, grabbing the exact piece of data you need, that can be a real headache sometimes. So today we're going to master this super important skill, data selection, so you can stop searching and start analyzing. You ever have that feeling you're staring at this massive data set, thousands of rows, and you just can't seem to grab the specific information you're looking for? Yeah, you are definitely not alone. It's like you're just drowning in a sea of rows and columns. Okay, but what if you could just reach in and pull out the exact thing you need with laser precision? Well, that's what we're gonna do. We're gonna give you the tools to find that very needle in your data haystack. Okay, let's kick things off with the absolute essentials, .loc and .iloc. I want you to think of these two like your personal data librarians. You walk up, you give them an exact shelf number, and boom, they hand you the book. It's that simple, that direct. So here's the absolute key difference you gotta get. Loc is all about the label. It's looking for the name you gave the row. Now, iloc, it doesn't care about names at all. It only cares about the position. Is it the very first row, the second, the 10th? And here's a little memory trick. The I in iloc stands for integer position. That'll help you remember. Now, I know this might seem kind of subtle at first, but trust me, it is so important. Think about it. A lot of the time, the label is the same as the position, right? So .loc 0 and .iloc 0 give you the same thing. But what happens when you sort your data? Suddenly, the row with the label 0 might not be in the first position anymore. .loc will follow that label wherever it goes, but .iloc? Nope. It's always going to grab whatever is sitting in that first slot, position 0, no matter what its name is. And hey, you're not just stuck grabbing entire rows. You can zero in on one single cell just by giving it the row and column coordinates, like df.loc 0, name. And here's a little pro tip for you. If you really need to squeeze out every last drop of performance when you're just grabbing one value, you should check out .at and .iat. They're optimized for exactly that. All right, so that's how we point to an exact spot in our data. But what if you don't know the location? What if you need to find something based on a description? This is where filtering comes in. We're not giving our librarian a shelf number anymore. Now we're walking up and saying, hey, I need a book about dragons that was published after 1990. We're asking a question. Okay, this is a spot where a lot of people get tripped up, but it's actually a super simple two-step dance. Step 1, you just write out your question, your condition, like is the age column greater than 30? What that does is it gives you back a whole list of trues and falses. Step 2, you take that whole list and you just stick it right inside the DataFrames square brackets. And like magic, Pandas only shows you the rows where the answer was true. That's it. Okay, simple questions are great. But what about more complex ones? Like, what if you need to find everyone who is both over 25 and lives in Delhi? You can totally do that. The rules for this are pretty straightforward. You use the ampersand for and this pipe symbol for or. But, and this is the big one, the golden rule you cannot forget. You have to wrap each of your conditions in its own set of parentheses. Seriously. If you forget this, Python will throw an error every single time. It's the #1 mistake people make here. So that whole Boolean filtering thing, it works. It absolutely works. But you've probably noticed, as your questions get longer, the code starts to look, well, a little ugly, right? Lots of brackets and parentheses. This is where the pros turn to something way more elegant, the .query method. It lets you write your filters in a way that is just so clean and easy to read. I mean, just look at the difference here. It's night and day, right? On the left, you got this mess of brackets, quotes, and that weird ampersand. And on the right, with .query, it reads like a sentence. You're literally telling the data frame, query where age is greater than 25 and city is Delhi. It's cleaner, it's easier to understand, and your future self will thank you for using it. And the best part is, the syntax is super intuitive. So let's do a quick fire round, a little playbook of the key rules so you can get started with this right now. Okay, the core rules, super simple. First, inside that query string, you just write your column names like they're variables. No quotes needed. Second, if you're checking against some text, a string, that needs quotes. Third, you use the actual words and, or, and not. Forget those old symbols. And last but not least, remember, everything is case sensitive. So what happens if you have a column name with a space in it, like first name? .query has a really neat trick for this. You just wrap that column name in backticks, that little key usually up next to the number 1 on your keyboard. That tells Pandas, hey, this whole thing, spaces and all, is one column name. Okay, now this next one is a seriously powerful feature. It's what makes your code super dynamic. Let's say you've got a variable somewhere else in your Python code, maybe an age limit that you want to use in your filter. So first, you just define that variable, age limit equals 30, just like normal. And then, and this is the cool part, inside your query string, you reference it by putting an @ symbol right in front of the variable name. That little @ tells Pandas, hold on, don't look for a column with this name, go look for a Python variable with this name and use its value. This is a total game changer for writing flexible, reusable code. And one last little bonus tip that just makes .querying so nice to use. You can chain your comparisons together just like you would in a math class or in regular Python. So instead of writing 2 separate conditions, age greater than 25 and age less than or equal to 40, you can just write it all in one go. It's so much cleaner to read. Okay, very, very important point here. Something that can trip up new users. When you run a query, it does not change your original data. It's not modifying anything in place. What it does is it gives you back a brand new data frame that contains only the results of your filter. So if you want to hang on to those results, you have to save them to a new variable. All right, so we've covered a ton of ground here. We've got .lock, .iloc, Boolean indexing, and the super slick .query method. So the big question is, which tool do you pull out of the toolbox and when? Let's break it down. Think of this as your cheat sheet, the final takeaway. If you need to grab something by its exact address, its label, or its integer position, you're going to use .lock or .iloc. For those really complex filters, maybe something you're building up step by step inside a function, the classic Boolean indexing is still your best friend. But for pretty much everything else, especially when you want your code to be super readable and clean, you're going to want to reach for .query. At the end of the day, selecting data isn't just about syntax. It's really the first chapter in the story that your analysis is going to tell. So as you're picking your tool, whether it's the precision of .lock, the raw logic of Boolean filters, or the beautiful readability of .query, don't just ask yourself, does this work? Ask yourself, which one of these makes my story the clearest? Because clear code, well, that's what leads to clear insights.